So last time we were talking about the execution of the instruction. It was said that the instruction is for transferring data from one external location into accumulator. Is it clear? So listen very carefully now. After reset, 8085 has read, obviously program counter has become 0. Then by using program counter as an address, the first machine cycle is of read cycle, is of the type read, and it is reading that to know what operations to perform. So it is called as opcode fetch cycle. Opcode fetch cycle means, as stated very clearly, 3A doesn't mean anything. It depends upon you are looking it in what context. So 8085 is reading it as an opcode, that is hardwired as a first cycle after reset. Then that 3A comes into instruction register or instruction decoder, where it comes to know that this is an opcode for bringing data from external memory location into accumulator. 3A happens to be the opcode for bringing data from an external memory location into accumulator. So it is a data transfer instruction. Its destination is, there is a single destination for this, that is accumulator. But what is the source? External location. If I tell you, bring something, the question would be from where to bring? So bring from external memory. So whether the instruction is complete? No. Instruction is not complete. What else is needed to be specified or to be understood by the microprocessor or by 8085 to completely understand the instruction? By 3A, bring to accumulator data from external memory. To completely specify the source, what else is needed? What is needed? Address. Bring from external memory location to accumulator. Which location? So external memory, there can be 65536 locations. Data from the sum of the locations, a specific location is to be brought in. So address is how many bit? 16 bit or 2 bytes. So that means 3A is not complete instruction. It is opcode. And for completing the instruction, how many more bytes are needed? 2. So 3 at the first cycle, which is opcode fetch cycle, what 8085 comes to know? How many bytes I am reading this is an opcode of a corresponding instruction, how much long that instruction is. So that must be read first, and then the step of execution. Just like you need to read the question paper first, then start answering. So next 2 bytes will be as a part of instruction. So what should be next? There is a convention. Again, why exactly there is no reasoning, just like right hand drive in India, left hand drive in US. So an external memory location will be specified. Let us say D1000, D000 or C0D0 or 8000. All these are examples of whenever no specific thing is mentioned, this is considered to be hexadecimal number. So it's a 16-bit number. It contains 16-bit number is 2-byte number in hex, so it contains 2 bytes, lower byte and higher byte. There is a convention that so what is there at address 0 in memory? At address 0 in memory there is 3A. 0000 contains 3A, which has come to now instruction register. Then next 2 bytes are specified at next 2 locations, and the logic, the convention followed by 8085 is low byte first and higher byte next. Means suppose if I have to bring the data from memory address 8000 into accumulator, what would be its assembly mnemonic? LDA 8000, and the assembly the machine code or hexadecimal bytes to be specified are 3A, the next byte is 00 and then 80. It's a convention, there is no specific meaning attached to it. So as stated, just when we go on reading the book, when I read my current page, I turn the page. So when program count is used to read first byte, it is automatically incremented. So next cycle should be what cycle? Whether the instruction is completely read? No, it is yet to be read. So next cycle must be a read cycle. Next cycle must be read cycle. Program counter will only give the address, what that will come as 0001 and again incremented. What is there? 3A 0080. So 00 would be there. Lakshya? The second machine cycle of LDA instruction is a memory read cycle. Remember, this is not a fetch cycle. Now 8085 is not reading the memory for opcode. It is now very much clear about what is to be done. At the end of first machine cycle, it has come to know that what next machine cycles are required. This is called as instruction decoding and machine cycle encoding. Means once the instruction is decoded, it comes to know what next machine cycles are to be sequenced for completing the instruction. So at the end of first machine cycle, it has completely come to know that the next cycle is a memory read cycle, and what is read? 00. So what should happen with 00? Where it should go? Where 00 should go? What is 00? 00 is lower byte of the external memory address from where memory read is to be performed, and that is to be put into accumulator. म्हणजे 00 काय आहे? तर 00 हा ज्या मेमरी ऍड्रेस मधला डेटा accumulator न्यायचा आहे त्या मेमरी ऍड्रेसचा लोअर बाइट आहे. सो वेर शुड गो? Anybody? Where? No. Suppose that nowadays every methodology changed, but let us say that 2-3 decades back, that time classroom we can consider something is being told by the teacher that is going to come in the examination. So students are listening it, right? But when they will be reading it, teacher is telling something in the class right now which will be required by them at the time of examination. So what is 00? 00 is lower byte of the 16-bit external memory address from where the instruction requires data to be read and put into accumulator. म्हणजे LDA instruction ज्या मेमरी ऍड्रेस मधला डेटा रीड करून accumulator न्यायचा आहे त्या 16-bit मेमरी ऍड्रेसच्या 2 बाइट पैकी लोअर बाइट म्हणजे 00. So 00 is available to the microprocessor right now on the external bus, which is required byte. कधी आता लगेच उपयोग आहे त्याचा नाही, कारण दुसरा हायर बाइट घ्यायचा आहे. So something which is available now and required data, what is to be done? It must be stored somewhere. आता कुठे समजा आता तुम्हाला मी असं सांगितलं की आता काही गोष्टी सांगतोय नंतर एक थोडा वेळ लागणार तुम्ही कोणी स्टोर करता आता त्याला सिस्टमॅटिक कोण दिसत नाही मला तो असेल तर मला काय वहीला अशी 5 नंबर देईल हे करेल रोज देईल असं त्या ठिकाणी स्टोर पण एखादा एक जनरल फार सिन्सिअर पण नाही फार होपलेस पण नाही असा एक ॲव्हरेज आहे तो कुठे स्टोर करतो साधारण असं की जे लगेच लागणार आहे वहीच्या शेवटच्या पानावर राईट सो इट इज रिक्वायर्ड इमिजिएटली सो व्हेअर शुड बी स्टोर्ड समजा रजिस्टर सी मध्ये चालेल का कॅन यू स्टोर रजिस्टर सी का नाही you justify why not C I say it is lower byte BC is a register pair so I can use BC register pair to as an address later on so C is lower byte why not in C why this lower byte is not to be stored in C which is the instruction काय सांगितले LDA म्हणजे इन्स्ट्रक्शन काय करणे अपेक्षित आहे लोड accumulator from one location into external to accumulator मग आता हे 00 ऍड्रेस थोड्या वेळाने लागणार आहे नंतरचं काम संपणार आहे so if I now put 00 to register C what kind of an irreversible and undesired effect will take place यात एवढं सांगितलं तर तुम्हाला उत्तर यायलाच पाहिजे if this 00 goes to register C what kind of undesirable and irreversible effect will take place I mean, no. Right now, so what is solution you have? No, not this data. This is the. Listen very carefully. Once you get the things clear, it is lifelong for you. See what is 0? What is 3A? Load accumulator from. The instruction is load accumulator from an external memory address, right? So its destination is inside 8085 that is accumulator and its source is outside and therefore needs 16-bit address to be specified as a part of instruction. So the mnemonic of the instruction, LDA, load accumulator, means LDA is not English word. LDA is just combination of English letters except the 8085 language it has no meaning. But there is some short form. Load LD, A is accumulator, right? So that automatically one gets acquainted with. And then LDA address 16 is the format of instruction means it's a 3-byte instruction with lower and higher byte specified in the instruction after the opcode. Okay, so 00 is lower byte of the address from where memory read is to be done. So one more cycle is needed to read the higher byte also and then actual reading should take place. But the question is that 00 is available right now. After the cycle is over it will not remain. So 00 needs to be stored inside the processor. My question is why not C? will say, no, I will use E or L, BC pair, D pair, HL pair. But why not? When I am asking why not C, there is a specific reason for that. What is the reason? I have said that if every time you keep a practice, whenever you have to prove that something is not supposed to happen, something is impossible, something cannot be done, then you try to prove it by negation. Assume that it can be done, and then assuming that it is done, proceed further to its effects, and then you will reach to some point which will make the thing happening impossible. लक्षात आलं? जी गोष्ट होणं शक्य नाही, होऊ नये अशी वाटते ती होती आहे, ती झाली असं गृहीत धरायचं, त्यानंतर पुढे पुढे जायचं आणि आपण अशा एका टप्प्याला पोहोचतो की जे आपल्याला डिझायरेबल नाही आहे, त्यामुळं ही गोष्ट होता कामा नये. So I said that if ever, for the time being, for the sake of argument, we assume that 0, 0 goes to C, it is going to cause an irreversible and undesirable effect. Irreversible and undesirable. Otherwise say, if something is undesirable but it's reversible, still you can say, okay, I can manage with it. If something is irreversible but not undesirable, still you should not have any problem. Is it right? But if something is irreversible as well as undesirable, that should not be allowed to happen. So what is the defect? What is the instruction? LDA. Register C itself is one of the variables. It is one of the registers in the 85U. So you must have a bigger program. So in that big program, you are assuming you are defining those variables for some purpose. So unless otherwise you specifically intend to initialize or change that a particular variable, it should not be changed automatically. लक्षात आलं का? नाही, प्रोग्रामिंग करताना तुम्ही जेव्हा असेंब्ली लँग्वेज प्रोग्राम डेव्हलप करणार तेव्हा 80 आतले जे रजिस्टर्स आहेत ते कुठल्या ना कुठल्या कारणाकरता तुम्ही यूज केलेले असतात. त्यामुळे ते तुम्ही स्पेसिफिकली बदललेल्या खेरीज आपोआप बदलले नाही पाहिजे. LDA instruction रजिस्टरशी काय संबंध आहे का? LDA instruction destination accumulator source external location. So it should not impact anything other than source and destination. Is the idea clear? So register C should not be used. Register B should. Then what is to be used? The thing which is used for such temporary purpose. ते कुठलं सांगितलं मी? WZ pair. WZ is invisible pair of the programmer. Invisible pair of the programmer means what? Programmer can't write move something to W, move something to Z. It is used by 85U on its own for internal purpose, so that programmer can't say that it should not be changed. Is it clear? So this should go to low register in WL pair. Z is lower byte, W is higher byte. So this goes to Z. Then what should happen next? What should next cycle? At least now you must be able to tell. If you are not able to tell, then there is no point of my exhaustive discussion. What should next cycle? Next cycle क्या पाहिजे? Whether the instruction reading is complete? Yes or no? अरे कळते का नाही? Not complete. So what should be done now? What should next cycle? Read or write? Read. Who will give address? Normally program don't give address in 95% cases. And always it is always implemented. What it will give? Then what is there? Where that should go? Now what should next cycle? What is the next cycle? In the first, now I want answer from you. In the first 3 machine cycles, 8085 has read the instruction completely. The instruction is LD 8000. Means this instruction intends to bring the contents of external memory location 8000 to accumulator. So it's a 3-byte instruction. In first byte it reads the opcode, and in next 2 bytes, it has read the address from where reading is to be done and put into accumulator. So what we done? What should be next? What should be next cycle? What? 8085 operates in machine cycle. So what should be next cycle? What? What write? Why? What to write? To be written where? Whether the accumulator is inside microprocessor or outside microprocessor? Where the source is? Source is inside. LDA, load accumulator from an external address. Load accumulator from memory, whose address is given as a part of the instruction. So the destination is accumulator, it is inside the processor. Source is memory, which is outside the processor. So what kind of operation is expected? Read or write? Okay? LDA instruction मध्ये मेमरी मधल्या एका लोकेशनचा डेटा की ज्याचा ऍड्रेस हा इन्स्ट्रक्शन मध्ये दिलेला आहे तो accumulator मध्ये आणायचा आहे. सोर्स आहे मेमरी, डेस्टिनेशन आहे accumulator. डेस्टिनेशन आहे मायक्रोप्रोसेसरच्या आतमध्ये, सोर्स आहे मायक्रोप्रोसेसरच्या बाहेर. सोर्स कडून डेस्टिनेशन कडे आणायचा असेल तर रीड का राईट? तुमच्या जे बाहेर काहीतरी आहे ते तुम्हाला घ्यायचं असेल तुम्ही वाचणार का लिहिणार? एखादी गोष्ट तुमच्या बाहेर आहे ती तुम्हाला आतमध्ये स्टोअर करून ठेवायची आहे. मग तुम्ही काय करणार? आतमध्ये लिहिणार ते नव्हे, तुम्ही काय करणार? सो 8085 ने काय केलं पाहिजे आता? रीड सायकल. सो नेक्स्ट इज रीड सायकल. रीड सायकल म्हणलं की काय आलं? सम रजिस्टर पेअर शुड सप्लाय ऍड्रेस. तर आता ऍड्रेस कुठे द्यायला पाहिजे? प्रोग्राम काउंटरने का? नाही. देन का प्रोग्राम काउंटरने द्यायचं नाही? Program counter is used to read the instructions continuously, but once the instruction reading is complete, आता तुम्हाला सांगतोय, समजा तुम्ही वाचायला बसला, पहिला चॅप्टर वाचला, त्याच्या पुढे एक्सरसाइज आहे. मग तुम्ही काय करणार? पहिल्या चॅप्टर वाचल्यानंतर लगेच एक्सरसाइज सोडणार का दुसरा चॅप्टर वाचणार? That depends on how you proceed, but in a normal manner what is expected? After reading the first chapter, you don't go for the second chapter. Complete exercise first. So when the program counter is used to read the first instruction, then what should be done? That पहिल्या 3 मशीन सायकल मध्ये 8085 न LDA instruction वाचली आहे, ती पूर्ण झाली आहे का? अजून नाही. So before next instruction begins, what should happen? This instruction should be completed first. So again here the instruction execution requires a separate machine cycle. Why? Because data is outside the processor and it is to be brought in. जे डेटा ट्रान्सफर इन्स्ट्रक्शन मध्ये एक एक्स्ट्रा सायकल कधी लागतं, समजा एखादी इन्स्ट्रक्शन आहे मूव बी कॉमा सी, तर सायकल लागणार नाही, बाहेर काही होणार नाही, आतल्या आत होईल. whenever either source or destination of the instruction is outside the processor, then an additional machine cycle is needed after reading the complete instruction. So for LDA instruction, it's a 3-byte instruction and it requires how many machine cycles? 3 plus 1, 4. 3 to read and 1 to execute. And so WZ will give the address. WZ giving address, that is now 8000. What is data? 8000 ला काहीतरी असेल, काय असं माहित नाही आपल्याला. So if at 8000 there is something, at 8000 there is 55, say for time being. So 55 will come on data bus, and where they should go now? 55 should go to accumulator. Is it clear? Right? No ambiguity. Now, then what will happen? पहिला चॅप्टर वाचला, एक्सरसाइज पूर्ण केला, मग काय करायचं? सेकंड चॅप्टर. सो व्हॉट शुड बी नेक्स्ट सायकल? Next cycle should be read type, but what kind of reading? Of course, first instance is over, it is reading is over, execution is over, then there should be next cycle of course fetch cycle, program counter giving. प्रोग्राम काउंटर के बदले नहीं है, तब तो कितनी होना? 0 0 0 2 होता है, इंक्रीमेंट आ रहा है 3 and again incremented. So let us say that just a minute.
आजा भाई मालूम नहीं, इधर आने के बाद देख क्या पता नाम तो अभी तो सीरो वाला मैम
we can now have next instruction which is exactly reverse. Is exactly reverse. So it is STA. This is LDA. This is STA. The opcode is 32. So at 0003 we have 32. 0004 we have 50. 0005 we have 60. So you complete 32. Where 32 will go? Where 32 will go? Instruction register, right? Go to instruction register. Then what happen? Next. Type address data. So what next? Next is program counter giving program counter giving 0004 type opcode page or read and where data, what is data? 50. Where 50 should go? Where 50 should go? What is the instruction? LDA, it was lower accumulator from. Then its complements STA. ST store accumulator. Store accumulator to or at. Store accumulator at a 16-bit address. So what is 50? 50 is the lower byte of the 16-bit address where the contents of accumulator are to be stored. So 50 is available now, required later. So it must be stored. याला उदाहरण देता है तर म्हैस रवंथ करते. रवंथ ती काय करते? तर जेव्हा चारा उपलब्ध असतो तेव्हा तो सगळा लागत नाही. पण कदाचित असं वाटत असतं तिला की नंतर मला जे आत्ता तो आहे माझं पोट भरलेलं आहे मला आता लागणार नाही पण मला तो नंतर लागण्याची शक्यता आहे त्याला असेल त्याला माहित नाहीये. So it is to be eaten and stored somewhere else. So when storage is needed, something तुम्ही लिहून जात नाही मी म्हणजे बोलतो ते कारण something which is available now and required later needs to be stored. एवढं नाहीये. Something which is available now, required later and is not available at that time needs to be stored. मग तुम्ही स्टोर का करत नाही तर available now आणि तुम्हाला नक्की खात्री आहे की it is not required at all. Then we don't store it. का तसं नाहीये. available लक्षात काय स्टोर करायचं जे आता उपलब्ध आहे नंतर लागणार आहे. आता उपलब्ध आताच लागणार आहे. स्टोरची गरज नाही. विषय संपला. आता उपलब्ध आहे नंतर लागणार आहे जेव्हा लागणार आहे तेव्हा उपलब्ध नसणार आहे तर ते स्टोर करायचं. जे आता उपलब्ध आहे पण नंतर लागणारच नाहीये मग नंतर उपलब्ध काही संबंध येत नाही ते स्टोर करायची गरज नाही. किंवा जे आता उपलब्ध आहे नंतर लागणार आहे आणि नंतर उपलब्ध होणार आहे का आपण ते युट्यूबवर टाकतो त्यामुळे तुम्ही त्याला स्टोर करत असाल. Is it clear? So the thing which is required available now, required later. 50 is available on the bus right now. आता पाहिजे ते नंतर लागणार आहे पण त्यावेळी नसणार आहे. Therefore it is stored in register Z. Then next is read program counter giving address 0005 60 goes to W. So in these three machine cycles, ATD has read the instruction store accumulated 6050. Store accumulated 6050. So what should happen further? What should be next cycle? It should be read. You should write cycle. Why? Store accumulated add. Where is the source? Inside. म्हणजे तुम्ही प्रक्रिया लेखक आहात, तुमच्या डोक्यामध्ये काही गोष्टी यायला लागल्या आहेत, त्या बाहेर कायम स्वरूपी जतन करायचे आहेत, तर तुम्हाला काय करायला लागेल? राईट. सो सोर्स इज इनसाइड मायक्रोप्रोसेसर, destination is outside. So that data transfer requires a memory write cycle, for which who should give address? STA instruction मध्ये ऍड्रेस दिला होता, तो ऍड्रेस मी आता वाचून WZ स्टोअर करून ठेवला आहे. So WZ should give address and that would be 6050. So WZ giving 6050, then acute इथं फक्त डेटा जेव्हा लिहितो तेव्हा इथं काय 50 goes to Z, 60 goes to W, पण इथं काय acute इथं पण ऍड्रेस आहे आउटपुट लाइन. So it is unidirectional, right? It is bidirectional. So in read cycle data goes to memory, gives data, that data goes to some inside register, and in write cycle one register pair gives address, one register gives data, and then A will give how much? What is the value? 55. So A giving 55 and a write cycle. Is it clear? A write cycle. So we will write. Is it okay? Then we will go through some further instructions. The next is program counter giving. Again it is incremented 0 0 0 6, a fetch cycle, and let us say that 3E goes to instruction register. This 3E happens to be the mnemonic of MVIA, move immediately to, means the previous one was bringing something from memory to accumulator. Now here I want to initialize with some my own value, so it is immediate addressing mode. So move to accumulator something which is part of the instruction. So MVIA 33. So 3E is the opcode of the instruction MVIA, means move immediately to accumulator. Like that there are various MVIs. Move one MVIA, one MVIB, MVIC. For each register there is one instruction which makes it possible for the programmer to initialize the given register with the value which he wants. So MVIA 3E goes to instruction register. So there it comes to know that it is how many byte instruction? So what is the mnemonic of MVIA? Or of MVI A data A. What does it mean? That it's a 2-byte instruction and the next byte will be the data which should go to accumulator. Right? So what should happen to the next cycle? At the end of the first cycle it comes to that it is 2-byte instruction. What the processor or 8085 should come to know immediately when it is the first byte of the instruction, it is how many byte instruction? It's how many byte instruction. So it's 2-byte instruction. When it is 2-byte instruction, next cycle has to be read. So read. Who will give address? Who will give address? Address what is that? Program counter. Program counter giving 0007. What kind of cycle? Read or write? Read. Instructions you read completely. So read cycle. What is there? I said MVI 33. So 33 is there. So 33 now when 8085 completes reads first cycle, it comes to know that I am going to read now a 2-byte instruction. So next byte will be there and the next byte is to be taken into what is the instruction? Move immediately to accumulator. So MVIA opcode and operand is 33. So next byte is the operand. So operand is immediate. So immediate addressing mode. What is the destination? Accumulator. What is the source? Immediate 33. A part of the instruction. Means the source, when source is outside and address is directly specified, is called a direct addressing mode. And and when source is part of instruction, it is called as immediate addressing mode, and destination is register. So destination is A, source is part of instruction, and 8085 has now read that part. So where 33 should go? Where 33 should go? कुठे गेलं पाहिजे? ते 3E जेव्हा इन्स्ट्रक्शन वाचलेली आहे मायक्रोप्रोसेसरला काय कळलेलं आहे? What is the instruction? Move immediately to accumulator. Move something which is there in the instruction as the next byte is to be moved to accumulator. So why 8085 is reading the second byte of the instruction now? The second byte of the instruction is the data itself which should be taken to accumulator. So data is available now. Where should go? It should go to accumulator. Then what is the instruction? Taking 33 to accumulator. Whether it is over? Yes. So no additional cycle is needed for execution. लक्षात आलं का? In case of LDA, किती byte instruction होती? 3 byte. In first 3 machine cycles, what 85 has done? It has read the instruction, but the instruction is bringing data from external location to accumulator. In first 3 bytes, what 85 has done? Read the opcode and read the address from where the data is to brought. Data is not yet brought. So since the operand is outside in the memory, we need one more cycle. But for this, operand is there in the memory, no doubt, but it is a part of instruction which we have read. So MVI A33 is a 2 byte instruction. In the first byte has read the opcode and the second byte is data itself. So that 33 goes to accumulator. Instruction execution is complete. So it is over. Right? I think next time we continue.